Okay, this is the second video that we have for right now. We're in day 5 of our area unit. We're talking about the area of a regular pentagon right now. Not pentagon, a polygon right now. So before we go back, just a couple of reminders from the last video. First of all, there is a long way to find the area of a shape. We could break it into right triangles. A pentagon with 5 sides would have 10 small right triangles, and if I can find the base and height for each one, I can just multiply it by 10. I have the area. Or I can memorize the formula. If I remember that n is the number of sides, s is the side length, and r is the apothem length, remember that the apothem is drawn to a right angle. That is extremely important. This is not the apothem. That's drawn to a corner. If I can take the apothem length times s times r, and I take 1/2 NSR, that is the formula for the area of a regular polygon. So let's start off. Let's just do a couple of example problems. Let's find the area of these regular polygons. Now I'm not going to do the one on the left because I just realized that in the last video I've already done that twice, so let's go ahead and skip that. Let's find the area of this shape over here. First things first, I noticed that this line that is drawn from the center to the side length does meet at a right angle, so that means that indeed is the apothem. That is r. I noticed that the length of a side is 6 units, so I've got s. I need to know then one more dimension. I need to know how many sides there are. So if I count, I go 1, 2, 3, 4, 5, 6, 7. That's a heptagon, isn't it? It's a regular heptagon. N is 7 because it's a heptagon. So the area of the shape is 1/2 times n, which is 7, times s, which is 6, times r, which is 11. So let's get the calculators out. If I take that and I multiply it out, I should get an area of 231 square units, whatever those units might be. Pretty simple, right? Now, if you want to go through and you want to do right triangles, so you're doing this and you're saying, well, that's got a height of 11 and it's got a base of 3, and so if I take 11 times 3, that's 33, which means this is half of 33. Okay? If you want to go through, then do that. So you've got 16.5 for every single triangle, and you have 7 sides. That'd be 14 triangles, so you take 16.5 times 14 triangles, and you would get 231 as well. Hey, be my guest. I think that that's going to get a lot harder. This is a pretty simple formula to memorize, 1/2 NSR. I would recommend, highly recommend, just learning it, memorizing it, flashcards, index cards, do something. Here's a tougher example. Notice in this one, and this is where it gets difficult. Ready? I'm not giving the apothem length, am I? The line that's been drawn that's 17 centimeters goes down to a corner. So I'm kind of in a world of hurt now until I can figure out, I'm going to rotate this. It doesn't matter which way I rotate it. I need to figure out this dimension instead. Now, this is why honors geometry students, this is why we do sine, cosine, tangent. See, that's a right triangle, and here's what I know. I don't know what this angle is. I really don't care what the angle is, but I do know that if I looked at this angle here, if I use that as the angle of reference, that this 17 happens to be a hypotenuse, right? And I'm looking for the side across from it, which is the opposite. Well, that'd be fine, except I don't know what that angle is, right? So that's a problem. I could figure it out. Some of you guys are probably sitting there going, well, I know that I could figure out the angle inside of a pentagon, right? Isn't that 108 degrees? So isn't there a relationship there? Yeah, okay. We could start, okay, maybe you're starting to figure this out now. Maybe I could know that angle. Here's another way to look at it. If it's 20 all the way across, how far is it from here to here? Wasn't that just 10 units from here to here? Oh, so I know that this is 10 and 17. Ooh, I got Pythagorean theorem, don't I? So let me present to you 2 different ways that I could find the apothem length. The first way is this. I could say that 10 squared plus, what do you want to call that? I don't want to call it O. Let's call it R for apothem. R squared is equal to 17 squared. Remember, the 17 goes by itself because it's hypotenuse. So I take 17, I square it, that's 289. I subtract 100. That means R squared is equal to 189. So R is the square root of 189. That's actually not going to break down at all, I know. So we're just going to leave it as that for now. I don't want to round my answer in the middle. If I did the square root of 199, just to show you, that's approximately 13.747727. Okay, let's just write out a few decimals. I just don't want to round my answer. I want to be careful of that. It's the square root of 189. Here's another way to do it. If this is 108 degrees, because I know how to find the angle inside of a regular pentagon, then I know that this angle here probably should be maybe half of that. So that would be 54 degrees, right? I'm showing you two methods because in the homework you're not going to have necessarily the option of using either one. There are going to be times when you're going to have to do Pythagorean theorem. There are going to be other times where you're going to have to do what I'm about to show you. See, here's what I know. This is the opposite according to the 54 degrees, and this is the hypotenuse. Opposite and hypotenuse, that sounds a heck of a lot like so to me, and SOHCAHTOA. So I know that the sine of the angle that I'm interested in is equal to opposite over hypotenuse. That means that the sine of, let me twist the paper here, the sine of 54 degrees in this case is equal to the opposite over the 17. What's on bottom? 17. So what do I need to do? Multiply both sides by 17. The opposite is equal to 17 times the sine of 54 degrees. So on my calculator, if I take the sine of 54 and I multiply it by 17, ooh, look at that, 13.75. Kind of what I expected, right? So there's two different ways to get the apothem length. Now, how do I find the area? So we're almost done here. The apothem length means that I'm basically ready to, having that solved means I'm basically ready to use this formula. 1/2, the number of sides is 5. Each side is 20 centimeters in length, and the apothem length is 13.75 units, or square root of 189, right? In fact, let's just use that square root of 189. So I go through, I multiply it out. Let's see, I can do this. Half of 20 is 10. 10 times 5 is 50. I've got 50 square roots of 189, and that would be square centimeters. Or if I want to go ahead and do an estimate, which you guys are probably all hoping for right now, I take 13.75 times 50, and I have, it's about 687.39 is what I'm getting, square centimeters. So there's your approximation. Much tougher problem, right? Because I'm not given the apothem length. So here's what you have to remember. That 1/2 NSR, this is a great formula. R is the kicker. When your line is drawn to a corner, you're going to have to go through and do some steps to find the apothem length, and that's the only thing that's going to make these problems difficult. Okay, is when you don't know the apothem and you have to solve for it. I think I've got two more example problems. Try to work through them in a hurry because this video is getting kind of long. I have a regular octagon. It has an area of 5,000 square centimeters. By the way, octagon, that means n is going to be 8, right? It has an area of 5,000 square centimeters. It has an apothem length, R, is 25 centimeters. What is the perimeter? Right? Well, let's go through and let's at least solve for what we know. The area is 5,000. That's equal to 1/2 of 8 times S times R. And you might be sitting here thinking, well, shoot, that doesn't help me out. I don't know S or R, so how can I solve for one? Well, let's go through real quick. 1/2 of 8 is 4. And if I divide that 4 out, 5,000 divided by 4 gives me 1,250. So 1,250 is what I get whenever I multiply S times R. Well, think about this real quick. Oh, man. Let's see if I can draw an octagon. If I take 8 sides... Oh, I did that. Sorry. That's not S. That's N here. 1/2 N S R. Oh, man, what am I doing? You know what? Let's scratch this problem. Act like it never happened. Ready? Let's start from scratch. Area is equal to 1/2 NSR. I'm sorry. 5,000 is 1/2. The number of sides is 8. Each side length, I don't have a clue, but I know that the radius, sorry, not the radius, the apothem length is 25. Man, does that make more sense? Jeez Louise, I'm struggling today. If I go through and I take 8 times 25, that'd be 200. Half of that would be 100. So if I divide the 100 out from both sides, I would find out that S is equal to 50. In other words, each side length is 50 centimeters in length. So what's the perimeter of the shape? Well, it's equilateral because it's regular, so I take 50 times 8, and I would have 400 centimeters for the perimeter. I made that problem entirely too complicated, didn't I? I apologize for that. If I didn't have to make a 10-minute video again to replace that, I'd go trim it out. Here we go. One more example. Find the area of a regular n-gon. So in other words, we don't know what n is. But we do know that its apothem is equal to 10 inches, and its perimeter is equal to 100 inches. Well, this is going to be kind of tough, right? I don't know how many sides to draw. I can't even really draw a picture here. But I know that the area is equal to 1/2 NSR. And I know then that 1/2 NS, I know R is 10. So at least I can combine those. 5 times N times S gives me the area. But I'm looking for the perimeter. The perimeter is 100 inches, right? So what's the relationship? Well, just keep in mind this. If I had a triangle, I knew that N is 3. And so if let's say that I knew that the side length was 10, I would take 10 times 3 to get the perimeter, right? If I had a square and I knew that, so N was 4, I would take 10 times 4 to get the perimeter. If I knew that I had a pentagon, and it's a regular pentagon, remember, so these are all the same, and let's say that I had a side length of 10 and n is equal to 5, I would say I've got 10 times 5, that's 50 for the perimeter. So in each of those cases, the perimeter is n times s. The perimeter is n times s. The perimeter is n times s. The number of sides times the side length of each one. 10 times 4. Number of sides times the side length. 10 times 5. Number of sides times the side length. Look what I got there. That's just the perimeter of the shape. Area is equal to 5 times 100. The area, I don't even care how many sides there are. The area is 500 square inches. So, that's a pretty, hey listen, that's an advanced problem. That's tough to do. But if you know the relationship, how do I find the area of a regular pentagon? The area of a regular pentagon is equal to the number of sides times the side length of each one. And if you remember that area is equal to 1/2 NSR, these two formulas are the crutch for doing everything. And remember, the one catch, the one thing that you're really going to struggle with, the one thing you'll struggle with is when you're not given the apothem because you've been given something like this that's drawn to a corner, or this that's drawn to a corner, or this that's drawn to a corner, right? Avoid that. You need the apothem, which is going to land at a 90-degree angle to a side length.